Okay, so we're continuing our lesson on periodic functions, and I wanted to start out the day by going over these homework problems. Okay, so problem page 78, number 5, we want to use the equation y equals a sine parentheses b parentheses x minus c parentheses plus d, and I like to start by finding a and d because they're my outputs. So remember, A stands for the amplitude, and you find A by looking at the max output minus the min output divided by 2. So we have to come over here. Our y-axis is our output, and you can see that the highest this curve reaches is 1, and the lowest it reaches is -5. So 1 minus a -5, all of that over 2 is 6 over 2, which is 3. So A is 3. And then D is the median, and it's found by doing the max output plus the min output divided by 2. So that would be 1 plus a -5 over 2, which is -2. So A is 3 and D is -2. Okay, so now let's look at the inputs, which are B and C. And you get the inputs by looking at your x-axis. And so B has two definitions. You can think of B as 360 divided by the period length, or if you're looking at the graph, B is just the number of cycles in 360 degrees. And we know this is 360 degrees right here. So to find the value of B, all we have to do is count up the number of complete cycles in 360 degrees. And so if we draw a line through our median, we get that. And so we'll count. And so this is 1 complete cycle there, and then 2 complete. We have 2 complete cycles and then a half a cycle more, so B is 2.5. Okay, so now it's time to calculate C, and C is the first input where the output is equal to the median and is increasing. So in a graph, that is simply, if you look at this median, which is right here, the first time your output intersects that median and is increasing or going up, that's where C is. And so it's happens to occur right at the beginning. So this one, your C value is 0. Okay, so if we put it all together, we have our equation y equals 3 times the sine of 2.5 times x minus 0 plus a -2, which of course we could rewrite y equals 3 sine of 2.5x minus 2. You don't need the 0 or the plus. Okay, so let's do this for number 6. Let's find A, and A is the amplitude, and it's found by the max, which I can see is 6, minus the min, which is -2. So 6 minus a -2 divided by 2 gives me 8 divided by 2. A equals 4. That's my amplitude. D is the median, and it's max plus the min over 2. So D is equal to 2, because 4 divided by 2 is 2. Okay, so now I need to find B. And B, when you're looking at a graph, the easiest thing to think of is it's the number of cycles in a 360 degree length. And I can see that I'm counting by 90s. and I'm going to go ahead and draw my median in, because it's going to be my pretend x-axis. Okay, so I'm going to count how many complete cycles I see, and I'll start here at the pretend origin, and I'm just going to draw out one complete cycle, and then there's a little bit more. And I also didn't use this part over here to the left, so I'm going to take this part, which looks like it's about 1/3 of 90. So I'm going to come over here and add it. So this is the same as that. And the reason I'm doing that is because it makes it easy for me to see that there are 1.5 cycles in a 360-degree length. So now I can find C, and C is the first input where the output equals the median, and the median is 2, and it's increasing. So it's the first input where the output equals the median and is increasing. So the first time this sine function where the output equals the median is right here. It's the first time it happens, and it's increasing. So I know that's right. So I have to figure out what the input is. And so this is 90, and I can see that it's cut into thirds, which is going to make C 30 degrees. Okay, so we put it all together and we get a function y equals 4 times the sine of 1.5 parentheses x minus 30 plus 2. Okay, so now we're going to leave the graphs and look at just actual data. And so remember, A and D are your output constants, and B and C are your input constants. And I always think A and D are easier to find. So what you want to do when you first look at your data is go through and find a couple of maxes and a couple of mins. You may not be able to find all 4 of those things, but it's just good to take a look at that. So you're looking at your output. Your output, that's where your max and mins are. And so if I go through, I see 15, 13.2, 10, and 5 is very low, and there's no other number lower than 5. So I know that's the first min that I've come to. And then I come over at 28.5 and I see another 5. So I have 2 mins, and here I'm going to start over with the max. So I have 15, 13.2, 10, 5, then up to 13.2, and then up to 15. So looks like my max is 15. So I'm going to label that. Okay, so now I know that the amplitude is the max minus the min over 2. So we have an output max of 15 minus an output min of 5. That's 10 over 2, so A is 5. And then D, which is my median, that's the max plus the min over 2. So that's going to be 15 plus 5 over 2 equals 20 over 2, which is 10. Okay, so now I need to find my B, which is an input constant. So B is a 2-step process. You have to find the period length first. And so the way you find the period length, it's looking at your inputs. Those are your inputs, but you look at your maxes and your mins to locate the inputs you're going to use. So if I use the formula max 2 minus max 1, okay, I know that the second time the max happens, which is 15, it happens at 19.5. So I'm going to put down the input where that max happens. And the first time the max happened, it was at 1.5. So you have to check that you put in your x values, 19.5 minus 1.5. You knew to pick those two because of where the maxes occurred. Okay, so 19.5 minus 1.5 is 18. But that's just the period. So it's a 2-step process. Step 1 is to find the period length. And then B equals 360 divided by the period length. So 360 divided by 18 gives you your B value of 20. So remember, B is a two-step process when you're looking at data. Okay, so now it's time to find C. And C, you have to memorize something kind of complicated, and the more you write it, the better you'll get at it. C is the first input. So it's going to be an input value where the output, you use the output to find the input, equals the median, where the output equals the median, that's part one, and it has to be increasing. Okay, so first thing you want to do is find an output that equals the median. So the median, remember, is my D value. So I'm going to start over here at 15, and I'm looking at outputs, 15, 13.2, and 10. There's an output that equals the median. Okay, so it's satisfying condition 1, but is it increasing? Well, you're going from 10 down to 5, so no, it's not increasing there, so we have to keep looking. So if we keep going, 10 goes down to 5, and then the output 5 goes from 5 up to 13.2. And so that means that it must have been 10 somewhere here. Okay, but it's hidden. It's not available in the data. So just even if 10 isn't in the data, we know that it had to cross through 10 if it went from 5 to 13.2. So we know that our input that we're going to be looking for is somewhere between 10.5 and 17, because C is the first input where the output equals the median and is increasing. So you don't overthink it. 10 is closer to 13.2, so our input value, we're just going to guesstimate, and I would guess it would be closer to 17, and I would guess that it would be about 15. It's just a guess. 10 is closer to 13.2 than it is to 5, so I'm making a guess of 15. If you guessed 14, that would be fine. If you guessed 13.5, that would be fine. C is the only value where we just have to guess a little bit, but it's the first input, so you have to remember it's an input. B and C are inputs, but you use the outputs to find that location. So we have everything we need. So our equation is y equals A, which is 5, times the sine of B, which we found to be 20, times x minus C, which we found to be 15, plus D, which is 10. Okay, so we may have done this one before, but I'm going to redo it. And so the first step is to look for some maxes and mins in your outputs. And I see a max here at 23, and another max of 23 here. And then if I'm looking for some mins, I see 17 is a min, and another one occurs here. So now it's time to find my amplitude. That's my A value, and that is the max output minus the min output over 2. And so the max is 23, and the min was 17. So that gives me an amplitude of 3. Now it's time to find the median, which is D, and that's max output plus min output, which is 23 plus 17 divided by 2, which is 20. Now it's time to find my B and C values, which are input values, and B is a two-step process. The first thing you have to do is find the period length. And the way you find the period length is to use the input at max 2 minus the input at max 1. So if I look at the input at max 2, I get 22, and the input max 1, I get 6, which gives me 16. You can check it. Input at min 2 minus input at min 1 is also 16. So we have the period is 16. Step 2 is to know that B equals 360 divided by the period, which is 360 divided by 16, which gives you a B value of 22.5. So now it's time to find C, and C is the first input where the output is equal to the median and is increasing. So I have to go through and look at my outputs and find where it equals 20 and where it's increasing. So if I start over here, the first output value I get is 20, and it's going from 20 to 23, so it's increasing. So C is the input where that occurs, and so C is 2. So now I can write my equation, which is y equals 3 times the sine of 22.5 times x minus 2 plus 20. Okay, so what you want to do for this problem is enter all this data in, and it's going to take a while. So you enter all the data in, and you can pause me and do that. And what you want to do after you get your data in, you do that by clicking Stat Edit on your calculator, and then go to Shift or second and the y equals, and turn your stat plot on, which I've got a screenshot there. And then if you hit Zoom 9 for Zoom Stat, you can look at your data. And so question 2 says identify all maximum and minimum points using the table or the scatter plot. So what I've gone ahead and done, in purple you can see I've circled all the minimum values. So I have 53, 50, 53. And then in green I've circled all the maximum values, 92, 90, 91. And I've circled them on my scatter plot. So you can actually count. This first green right here is 1, 2, 3, 4, 5, 6, 7 dots away right here. And so that corresponds to July and the 7 and the 92 here. After you look at that, what we can do to find the value of B is remember that B is an input. Okay, so we have to look at the inputs where the outputs happen, and so B is the input we can do max 2 minus the input at max 1, or we can do input at min 2 minus input at min 1. So if I just do the maxes, then what I'm going to do is look at this 90 right here, and you can see that it's the 19th month when 90 degrees occurs, minus the 7, which is where the input at 92 is, and so you get, excuse me, this is not B, this is the period length. You get the period length is 12 months, because that's what your units are, months, and so that should make very much sense to us since we know that there are 12 months on our calendar. Okay, but that's not B, that is the period length. So to find B, I have to do 360 divided by 12, and so I get B is 30. Okay, and then to find the value of A and D, A is your amplitude, and that's what you get when you do it's an output, so that's the max output minus the min output over 2. And so there's a little bit of variance between your maxes and your mins, but the highest max that I found was 92, and the lowest min is 50. So those are what I'm going to use. And that gives you 42 divided by 2, which is 21 is your A value. And then your D value is going to be 92 plus 50 over 2. So 92 plus 50 is 142 divided by 2. So that would be 71. And then your C value is the first input where the output equals the median and is increasing. So we need to look for the first time we cross through 71. And so if I start here at 54 at the top, you see where my pen is, and I get to 68, and then get to 75, then 71 occurred somewhere here, and it's increasing. So that means that my C value is somewhere between 3 and 4. So I'm going to let C equal 3.5. Okay, it says put your values A, B, C, and D into the equation, and so that's what we'll do. So Y equals 21 times the sign, parentheses B, which is 30, parentheses T, minus C, which is 3.5, plus D, which is 71. Okay, so if you were to graph this Y equals in your Y equals and graph it, you would see that this equation fits our data very, very well. Okay, so what I want to do now is go ahead and explain in real-world terms what each of these values means so that you'll be ready for the word problems and the test. So if we start here at A is an output, so that means that A is a temperature, since your temperature is your output. So A is 21 degrees, and D is a temperature. D is the 71 degrees. Now D is the median, and what this is, D is the average temperature for our area. So we average 71 degrees temperature-wise for our area. And what the A is the amplitude. And so what that means is this gives you the change in temperature. So if we add 21 to D, we get 92 degrees. So that's our high. In 92, that's the average temperature. If we subtract 21 from 71, we get 50, which is our low temperature for winter. And so the amplitude gives you the high that you have to add 21 to get the high to the median, and you have to subtract 21 to get the low from the median. Okay, so B is not very good when it comes to explaining what's going on in the real world with this one. B is the number of cycles in 360 degrees. So there are 30 of our cycles in 360 degrees. Well, 360 degrees has no real world application here, so it's actually better to talk about what the period means in the real world, and we've discussed that. The period is the number of months that it takes to complete our temperature cycle, and so we know that it takes 12 months to complete one of our temperature cycles. So when you're asked to interpret, it's easier to interpret the period instead of B. And then finally, C is interesting. C is an input, just like B. So 3.5, the units would be months, because that's what our input variable is, units are. And so what that means is it's going to be 3.5 months into the year when we first reach our average temperature. And so that's about the middle of March, which means in the middle of March our average temperature is 71 degrees, which can tell you, we were very cold this March. But that's how you interpret those values. Okay, so page 83, number 1. Recorded in the table below are the daily revenue totals for the movie Titanic 16 days after 12/19/97. question A, find the period and the value of B. So the first thing that we need to do is we need to find some maxes or some mins. I'm just going to start with the maxes. So I have a max here at 12.7, and I have a max here at 12.5. Okay, so remember now B, you have to find the period first. And the period, the B is an input constant. So we're going to use the outputs, but we're going to write down the inputs. So the period is the input that happens at max 2 minus the input that happens at max 1. And so 23 minus 16 gives us 7. And then B is 360 divided by 7, which is 51.43, and the units would be days. Okay. So now we need to find the median and the amplitude. So if we find A first, A is an output constant, so we need to find just the max and the min, the output. So I found the maxes. Let's look at for the mins. There's a min of 2.8. There's a min of 2.3. That's the smallest min, so I'm going to write that, use that one. But there are some two mins. And so what we'll do is we'll do A is max output minus min output over 2, which gives us 12.7 is the max, and 2.3 is the absolute min. That, oh, there's a 2.1. Let's use that. All right. So 12.7 minus 2.1 divided by 2 is 5.3. And then to find D, it would be max plus min over 2, which would be 12.7 plus 2.1 over 2. Which is 7.4. Okay, and then it says write a periodic function for the revenue R in millions of dollars for the movie Titanic in terms of X, where X is between 16 and 36. Do not use regression. Okay, so what we need to do is find C. We haven't found C yet. And so C is the first input, where the output is equal to the median and is increasing. Okay, so our median is 7.4. So I'm going to go to 12.7 right here, 8.8 to 2.8. So 7.4 is somewhere in here. The problem is it's not increasing, it's decreasing. But if I go from 2.8 to 7.8, then 7.4 is right in here, and it's increasing. So that means that my C value's in between 20 and 22. And this is just an estimate. So I would take anything from 21 to 21.5. I'm just going to go ahead and say 21.5. Okay, so now we can write our function. And that would be R of X is equal to 5.3. That's our A value. Times the sign, 51.43, parentheses X minus our C value, plus our D value of 7.4. Okay, so if we look at the units on this, the D is an output, so that would be $7.4 million. That's the average revenue. And our A would be $5.3 million. So to find the peak, I would have to add 5.3 to my median, and to find the valley, I would have to subtract 5.3 from my median. We've talked about the B value and the C value. That's our horizontal shift. That's an input, so that's days. So 21.5 days in, we hit the median of $7.4 million. Okay, so this number 2 question is about a tsunami. It's a wave created by an earthquake in the ocean that causes the water level to change. The water level change W in meters of a hypothetical tsunami m minutes after it was created is recorded in the table below. Question A, determine the period of the data and interpret the value in context of the problem. Okay, so what we need for the period is we need either 2 maxes or 2 mins, and they have to be side by side each other. So I'm just going to, since 2 is a min that I see, I'm going to go ahead and use that as my min 1. Then it goes up to 9, up to 17, back down to 13, back to 4, back to 1. So that's the second min. And the period is, you have to look at the input. So I'm not going to do 1 minus 2. I'm going to do the input at the min 2 minus the input at the min 1. So that would be 15 minus 0 is 15. And the units, since this is an input, would be minutes. So to interpret this, it's going to take 15 minutes for a wave to complete its cycle. Okay, so that means that if you saw a wave at its highest peak, it would take 15 minutes before you saw the wave at its highest peak again. Okay, it takes 15 minutes for the wave to complete one cycle. Okay, B, determine the median and the amplitude of the data and interpret these values in context of the problem. So A is an output constant, and we need a max. So it's the max output minus the min output. And I haven't found a max yet, so let's go look. You can see 17 is the highest number that I see, and 1 was the lowest, so we'll use that. We've got to divide this by 2, so this would be 17 minus 1 over 2, which is 8. And the units on that would be meters. Okay, D is the max plus the min, so that would be 17 plus 1 over 2, which gives you 9 meters. Okay, so if we want to interpret that, we would say that the average height of the wave would be 9 meters, with a peak at 9 plus 8 meters, or 17 meters, and a valley of 9 minus 8 meters, which would be 1 meter. Okay, and I've written out the interpretation. So the median is 9 meters, which is the average height of the wave, with a max height of 17 meters and a min height of 1 meter. So when I wrote that out, I was interpreting A there. Okay, so the last part, C, use the calculations in part A and B to write a periodic function. So we found A and D. We haven't found B yet, but we have found the period. So B is 360 divided by 15, which is 24. So now we have B is 24, and then C is the first input where the output equals the median and is increasing. And the median is 9 meters. So if I look at my data, there is a 9 right here, and it's increasing. C is an input value, so C is not 9. C would be the input where that occurs, which is 3. So my function would be W of M is equal to 8 times the sine of 24 times M minus 3 plus 9. Okay, so what you want to do is page 84, number 3 and 4 on a separate sheet of paper, and you'll want to bring that to class with you on Tuesday. Okay, we're not done yet, so going. the objectives: given a periodic function, interpret in context of the problem the max and min values, interpret the period, and find a periodic function without using regression on the calculator. Okay, so now we're going to do a few where I've just given you the equation and you have to interpret each value. So this one says the following function models the hours of daylight in Raleigh, H, as a function of the day of the year, D. Identify A, B, C, and D, and interpret each value in the context of the problem. Well, it's all about units, so what I'm going to do first is write down what each of what D stands for in terms of my units, and D is days, and that's my input, and H is my output, and that stands for hours of daylight. Okay, and we know that the function y equals a sine parentheses b parentheses x minus c plus d is the equation that I can use. So finding a, b, c, and d is not hard, it's interpreting it. So A is 2.42, and A is an output, so 2.42 hours of daylight is my A. And D is 12.17 hours of daylight. And I like to interpret these together. In fact, I would, because D is the average. Okay. So if I wanted to interpret this, I would say the average number of daylight hours is 12.17 hours with a peak number of whatever 12.17 plus 2.42 is. 14.59 hours, and a valley of whatever 12.17 minus 2.42 is. A valley of 9.75 hours. And I've just said peak and valley. You could say max and min, maximum and minimum. But when you're interpreting A, B, C, and D, you always interpret A and D together. So the average is D, and the maximum occurs when you add A to D, and the minimum occurs when you subtract A from D. So to interpret B, B is 3, and B is the number of cycles in one 360-degree period. But that's not very easy to interpret. So when I ask you to interpret B, really, you need to use B to find the period length. And so the period length is 360 divided by B. So 360 divided by 3 is 120. And B is an input, so the units on this would be 120 days. And the interpretation would be it takes 120 days for daylight hours to complete one cycle. Okay, so it takes whatever the period length is for your Y to complete one cycle. And that's how you interpret B. You find the period length. Okay, and then C is the number 80, and that's an input, so that's 80 days. And what that means is 80 days into the cycle, you reach your average number of daylight hours. Okay, 80 days into the cycle, you reach the average number of daylight hours, which is D, which is 12.17. Okay, and so if we were talking in context of this problem, if we let 0 be December 31st and January 1st be 1, 80 days in, that's around the middle of March is when you're going to get the average daylight hours of 12.17 hours. And I'm not sure if this is accurate or not. Okay, this page is a little screwed up, but we'll do the work on the next page. Another example, the demand for temporary employment in thousands of job applications per week, D, can be modeled as a periodic function of time, T, in years, since January 1995 by the function, which is hard to see. It says D of T equals 4.3 sine 45, parentheses T plus 0.5, and then your D value is 7.3. And this question is asking you what was the demand for temporary employment in January 2001, and when will the demand for temporary employment reach a maximum for the first time, and what is the maximum demand for temporary employment? Okay, so what I've already done is, what we want to do is use the calculator for this. So if you would type in, go to y equals and type in the equation, and then your window, I've done it for you, but you really should be able to find that yourself by thinking about what X stands for. X is in years, since 1995. And so I thought, well, let's look at the first 20 years after 1995. And then Y is the number of job applications in thousands. And so here's what you can do to figure out Y. If you take your D, 7.3, and add your A, you get the max. So you're going to have a max of 11.6 job applications in thousands. So your Y just needs to go at least as high as 11.6. So I went up to 20. And I went down to negative 20 to get, a nice, good view. Okay, so the first question that we got to answer is B. What was the demand for temporary employment in January 2001? So this is T. 2001 minus 1995 gives you a T value of 6. So this is an input-output question. And so what I did is used second calc value and then typed in X equals 6. And I like that because I get a cursor, and it's really helpful to see that cursor. And so when I found it, I got the ordered pair right here of 6, 3.32. So the answer to B is 3.32 thousand job applications. So our demand in 2001 was 3.32 thousand job applications, because this ordered pair on the calculator was 6, 3.3. Actually, it should be 3.33. Let me correct that. 3.33 thousand job apps. Okay, so the second question says, when will the demand for temporary employment reach a maximum for the first time after January 1995? And what is the maximum demand for temporary employment? Answer in a complete sentence. Okay, so you have to look at the graph and see where the maximum for the first time occurs, and that occurs right here. That's the first time the maximum occurs. This would be the second time, and that would be the third time. We want the first time. Okay, so what you want to do is use second calc number 4 and go a little to the left of this value and hit enter, and go a little to the right of that area and hit enter, and then hit enter again, and you'll get 1.511.6. So now it's time to answer the question, when the demand will reach a max in the middle of 1996, since it was 1.5, and the max demand is 11.6 thousand job applications. Okay, so I want you to complete page 85 and 86, numbers 2 through 5. That's also due on a separate sheet of paper on Tuesday. Okay, so you have a lot of things due. You want to make sure you complete problems 3 and 4 on page 84 on a separate sheet. The problems on 85 and 86 that we just mentioned. The project is due Wednesday, April 24th. WebAssign is due Sunday, April 21st. And your optional WebAssign Test 4 review date is due Thursday at 10 a.m., the 25th.